Hello, my name is Carlos Lopez Ordonez and I'm going to talk to you about the urban growth and density in a low dispersed and hot desert climate city. Urban density is commonly used to measure life quality in a city, and together with a compact urban morphology, they are often seen as prerequisites for sustainable urbanization and economic growth. Even though high density seems to be the best approach, the actual trend at a global scale follows the opposite way. In this graph, we can see that in almost all the cities represented, the population density has decreased in a lapse of 15 years. In hot desert cities where the climate is one of the main parameters to consider to achieve a quality urban life, a sprawl development that leads to low densities is not recommended. These cities are located in low-medium latitudes, concentrating a large part of the world population. Historical desert cities such as Cairo or Alexandria present a compact form with high densities. However, modern desert cities such as Riyadh in the Middle East, Khartoum in Africa, or Phoenix, Las Vegas, or Mexicali in North America present urban sprawl development with low densities. It is within this framework that this study focuses on the city of Hermosillo in Mexico. The goal of this work is to evaluate the urban growth and the change in density of Hermosillo, to provide urban planning strategies that could improve the quality of life. For this, it is necessary to include three different aspects: the distribution of population density, the distribution of vacant lots, and the relationship between urban form and climate, especially solar radiation. The methodology used in this work is divided into three phases. The first consists of the data collection from the National Institute of Statistics and Geography, the National Meteorological Service, and other cadastral sources. In the second, we process the data using GIS tools. The third phase is the assessment of solar access at street level in a representative area of the city. Hermosillo is located in the Sonoran Desert and is the capital of the Mexican state of Sonora. It follows a dispersed city model with single-story dwellings, wide streets, and low edificatory densities. As a desert city, it has clear skies and high levels of solar radiation throughout the year, with low humidity. The annual mean temperature is 25 degrees, but during the hot season, the city presents temperatures of 40 to 45 degrees, sometimes reaching 50 degrees. Since the second half of the 20th century, Hermosillo has maintained an accelerated rate of urban and population growth. In the meantime, for the last 30 years, it has followed a housing policy that favors the construction of single-family dwellings in close neighborhoods. Nowadays, Hermosillo has a population of over 800,000 and it is expected to increase its population by up to 35% while maintaining low-density values. This map shows the city distribution of population density. While in most cities the density starts to decline while increasing the distance from the city center, in Hermosillo it is quite the opposite. This low centrality effect means that the inhabitants and certain economic activities tend to move from the city center to the outskirts of the city. This causes the urban center to lose economic and population weight. This map shows the distribution of the existing vacant lots, which are areas without buildings regardless of the time of land use. There are around 34,000 vacant lots. This amount is equivalent to approximately 5,000 hectares, that is 30% of the urban area. Regarding to the relationship between urban form and climate, the area selected for the assessment is the city center. This is the area with the highest construction density and the highest average building height. Therefore, this area should present the lowest levels of direct solar radiation of the streets. However, the layout of its streets and the low height of its buildings allow for a high level of penetration of solar radiation at street level. This can be seen in the solar diagrams. The map on the left shows the solar radiation accumulated per square meter throughout the hot season. You can see how most of the streets receive a great amount of direct solar radiation. The graph on the right shows the maximum possible solar irradiance, here in the black dashed line, and the actual irradiance received, in the gray solid line. The blue dotted line represents the percentage difference between them. This reduction produced by the urban form itself varies from 16 to 32%, maintaining an average of 20%. After observing the relationship between urban form and climate, it seems necessary to define strategies for an urban planning policy that include these aspects. We propose two strategies. The first is the infill of the vacant lots that are within the consolidated urban area, implementing mixed-use lots. This could mean an improvement in terms of a slight increase in urban density and could help to reduce the typical zoning of dispersed cities. The second strategy is the creation of urban subcenters in different areas of the city to counteract the typical continuous expansion of dispersed cities, thus limiting the urban sprawl and increasing urban density. These subcenters need to have a high density and a morphology that allows the creation of shade in public space to protect the pedestrian for the high incidence of solar radiation, while acting as an urban oasis network, as can be seen in the map. In the case of the urban center of Hermosillo, these two strategies could be applied while taking advantage of the fact that it is an active commercial area and counts with all the public services. This can be done by the infill of vacant lots and the stacking of homes on top of the current buildings, whose construction permits it. This will allow the diversification of land uses and increase in building and population density, and lead to an improvement in the quality of public space, therefore of urban life, while acting as a catalyzer for other zones of the city. Thank you for the attention.